Welcome everyone to this video where we will be talking about electrical current. We learned before that in order to turn on a light, electrons must carry energy through a conductor and pass through this light or lamp, where this light or lamp will use the energy inside these electrons, and these electrons will go back to the cell or the battery to take more energy. We said that we will be going more in details about these simple circuits. So today we're going to be talking about electrical current. Now, it's clear that not all types of electrical devices use the same energy. Some of them need high energy and some of them need low energy. Well, the electrical current is some indication of how much energy am I giving this device. Okay, so in order to study that or to understand that, we need to know how many electrons are passing this wire each second. But we said before that if we have 6 million electrons, we will have something called one coulomb, right? So instead of using that electrons are passing through wires, we will be saying that coulombs are passing through wires. We will not use the terms electrons passing through wires anymore. We will be saying that coulombs or charges are passing through this wire. But enabled to make our calculations more measurable, we will be saying, or we will be using the term electrical current. So simply, the electrical current is the number of charges, or in other words, coulombs, passing through a wire each second. We will call this the electrical current. Once again, the number of coulombs passing each second. So if we have 5 coulombs passing each second, we will have electrical current equal to 5. But 5 what? What's the unit of current? The unit of current is called amperes, okay? The unit of current is called the amperes. We will use a simple device called an ammeter. We will use a simple device called an ammeter to measure the current inside a circuit. So we introduced what an electrical current is. We introduced the unit of electrical current, and we introduced the ammeter, which is the device used to measure the electrical current. A very simple equation will be used to calculate the electrical current inside a circuit. As we said, we will be using the letter I to represent current, and the unit of current is amperes. T in this equation represents time, which will be in seconds. It's important to keep in mind that when we calculate the current, time is in seconds. It's very important to know that. And finally, Q, which is the charge passing through the wire, and we know that the unit of charge is coulomb. So I is equal to Q over T. It's very simple. To make this illustration easier to understand, to make it closer to a mind, we will be showing you a simple illustration about what we're saying right now. To understand this illustration, first we need to know what every symbol in this picture will mean. First of all, we will start with this shape. This shape, we will mean by this shape that we have one coulomb. Actually, it's kind of a truck. So this is equal to 6 million electrons. One coulomb is equal to 6 million electrons, and we will represent the coulombs by using a symbol of a truck. And this is what we introduced before. We called it a battery or a cell. The batteries will give the trucks, or what we call the coulombs, energy. So energy will be given from this battery to this truck, okay? And we will be using an ammeter to measure the current in this circuit. Finally, this is the source that will be using the energy, which is simply a lamp. Now let's look at this picture. It's an illustration of what we said. Let's start from this point right here, okay? So from this point right here, we can see that we have trucks. They are entering the cell or the battery. They are given energy inside this cell and given energy inside this cell, and they are leaving from the other side carrying energy. So the green balls here, we can illustrate them, or we can say that this is the energy. Now, a coulomb carrying energy. Did we ever see this term before? Yes, we said if we give one coulomb 1 joule of energy, we will have something called 1 volt, just to remember. Now, these coulombs are passing through, these coulombs carrying energy are passing through an ammeter right here. We can illustrate it by using the letter A. So what this does here, it's just simply counting how many columns are passing each second. Once again, an ammeter is simply counting how many trucks or columns are passing each second. Now, these trucks are moving to the other side, as you can see, towards the lamp. When they enter the lamp right here, the lamp will be taking all the energy or part of this energy. In this example, it's taking all of the energy, but it doesn't always have to take all the energy inside these trucks. And they are leaving from the other side carrying no energy because the energy was taken by the lamp. And they go back to the cell, carry more energy, and etc. So this is a more detailed illustration of a simple circuit. The columns or the trucks will be taking energy. The ammeter counts how many columns are passing each second, and these columns carrying energy are passing through a lamp, and the lamp uses this energy. I hope that this makes the term electrical current a lot more clear. For our information, we need to know that the electrical current inside a circuit can be either something we call it the direct current or DC for simplicity, or it can be something called AC, alternating current. So the direct current means that the electrons are always moving in one direction. That's clear. Yeah, we know that electrons are moving in one direction. But there are some cases where the electrons will go back and forth inside this circuit. We're not going to go more in details about this right now, but we have to see these illustrations that will help us understand how the electrical current in a direct current works and in an alternating current works. Look here at this image. If we have a battery, the battery is giving energy to these electrons, and as you can see, they're always moving in the same direction, right? We can illustrate this by saying that the voltage is always in the positive side. Look here, this is the positive side of the graph, and this is the negative side of the graph. As you can see that the voltage is always in the positive side of the graph. It's not a problem if you don't fully understand what's being said right here. We will talk about this more in detail later, but we want to introduce the terms DC and AC. And actually, direct current is normally given by batteries. So batteries normally give me something called the direct current, okay? Now let's look at the alternating current. From the word alternating, it's going back and forth. Look at the electrons here. The electrons are simply going back and forth. The same electron here is going back and forth inside this source of energy. Well, the source of energy this time is not a battery, because batteries are not always the source of energy in alternating currents. What other sources of energy are there? We will be talking about that later. But it's important to understand that in an AC wave or alternating current wave, we can see that sometimes that potential difference or the voltage, as you can see, it's positive and sometimes it is negative because the energy is alternating. One of the main sources of alternating current is something called the AC generator. And as I said before, we will be talking more in details about generators and how they generate electricity for us. So that's all what we have to say about electrical current. Stay tuned in the next video where we will be solving problems about electrical current.